Today we're going to study a very interesting chapter, refraction at plane surfaces. You know what happens when a light ray strikes a glass slab? Exactly what path does it follow? Let's find out. You see, when a light ray strikes a glass slab, or for that matter, any medium which is different from vacuum, it undergoes refraction. That is, it gets deviated from its original path. So this light ray, which was incident at an angle θ1 with respect to the normal at the surface, is now traveling such that it forms an angle θ2 with the normal. And you can even calculate the deviation of the light ray. The deviation is clearly θ1 minus θ2. So exactly, what laws does the light ray follow when it gets deviated while passing through another medium? Let's find that out. There are two main laws of refraction. As you already know, refraction is the bending, or the change in the path of the light ray when it encounters a different medium. Here's the first law of refraction. The light ray in the two media and the normal to the interface surface at the point of incidence lie in the same plane. The ratio of the sine of the angles made by the light ray in the two media with the normal to the interface surface at the point of incidence remains constant for a given pair of medium. Now, all these heavy words seem to be pretty confusing. Like, what exactly are the laws of refraction? Let's understand using some pictures and animations. Let's consider this glass slab. Now, when a light ray strikes this glass slab, it gets refracted like this. The first law of refraction states that the incident ray, the refracted ray, and the normal at the point of contact, all of them lie in this same plane. This is very important. The second law of refraction says that if the incident ray is striking like this and the refracted ray is passing through the second medium like this, then the angle θ1 and θ2 will be such that sine θ1 by sine θ2 will be constant for a given pair of mediums. So if you take air and glass, then for them this angle sine θ1 by sine θ2 will always be a fixed quantity, like no matter what else is happening in this world. In fact, this ratio sine θ1 by sine θ2, as you might already have studied in class 10th, is called mu, the refractive index for a pair of media. So if the light ray is coming from medium 1 into medium 2, the refractive index will be 1 mu 2. 1 mu 2 will represent the refractive index of medium 2 with respect to 1. So if medium 1 is air and if medium 2 is glass, sine θ1 by sine θ2 will represent the refractive index of glass with respect to air. Okay. In fact, this particular law, which states that sine θ1 by sine θ2 is constant, is called Snell's Law, as you might already have heard. When we say 1 mu 2 equal to mu 2 by mu 1, we mean that the refractive index of 2 with respect to 1 is equal to the refractive index of 2 divided by the refractive index of 1 with respect to vacuum. So mu 1 represents the refractive index with respect to vacuum, and mu 2 represents the refractive index of this medium 2 with respect to vacuum. So if you say that this is air here and this is glass here, in that case, A mu g, that is the refractive index of glass with respect to air, will be sine I divided by sine R. Where I is the angle of incidence with which the light ray is incident on the glass slab, and R is the angle of refraction in the glass slab. And this will be equal to mu glass divided by mu air, where mu glass is the refractive index of glass with respect to vacuum and mu air is the refractive index of air with respect to vacuum. So mu glass represents the refractive index when a light ray from vacuum is incident on the glass slab, and mu a represents the refractive index when a light ray from vacuum is incident in air. So this is something you'll have to understand and remember, that A mu g will be sine I by sine R, which will be equal to mu g by mu a. Understood? If yes, then let's proceed. There was this one scientist called Huggins, and he researched more on this phenomenon of refractive index, like exactly what does sine θ1 by sine θ2 represent physically and things like that. What Huggins found out was that we say that 1 mu 2 is sine theta 1 by sine theta 2. This is also equal to c1 by c2. He found this out by experimentation. You know that sine theta 1 by sine theta 2 is equal to the speed of light in medium 1 divided by the speed of light in medium 2. So what he found out was that, if we're talking about the refractive index of glass with respect to air, which is equal to the refractive index of glass divided by the refractive index of air, then this is also equal to the speed of light in air divided by the speed of light in glass. Isn't that interesting? Huggins found this out. Now we've hardly, started this chapter. We've just started studying it. But we are already ready to solve an IIT JEE problem. So let's solve it. This question was asked in IIT JEE 1999. Oh, it's a large question, a lot of data and details. The XY plane is the boundary between two transparent media. Medium 1 with z greater than equal to 0 has a refractive index of root 2, and medium 2 with z less than equal to 0 has a refractive index root 3. A ray of light in medium 1 is given by the vector, this particular vector. This is incident on the plane of separation. Find the unit vector in the direction of refraction in medium 2. Oh, this question has actually complicated such simple concepts that we just learnt. In the question, the vectorial representation of the incident ray is given, and we have to find out, the unit vector in the direction of the refracted ray. I am sure this will really explore the core concepts of refraction. Let's see how to proceed in this problem.